you're going to see for the first time a disclaimer. I think as we get wider, we're being increasingly careful about the front end of what we're doing here. So just the lawyers, the counsel's advising, this is not an offer or a solicitation. This is really us communicating information to you all. So no funding is expected off of this call. Your indication of interest is really a request to kind of move forward and not an obligation or a commitment. So got to go through the boilerplate there. As we grow and get more visibility, this is really important to state. So we're not expecting anything out of you other than just learn some amazing things from amazing founders. So that's it in terms of the intro and prelude. We're going to hand it over to Jared. Jared is a founder that we've gotten to know quite well over the last couple of months. I think he's the epitome of a frontier generational founder, amazing background. Jared's going to go into his inspiration for Keiro, his background, and where he's coming from, where he's going. So he'll go into this, but Jared previously, he got his PhD under pretty much the Mount Rushmore of AI and data science. The folks like Zaharia and Leskovitz, who were the inventors and founders of Apache Spark, Databricks, GNNs as well. And so that's the group that Jared comes out of. He's a serial entrepreneur, serial founder. He's already got a company that he's founded called Mithril. We'll talk a little bit about that. They were invested by the who's who of VCs, co-led by Sequoia Lightspeed, NEA, and the Jeff Dean was a personal mentor and investor into this cohort as well. So that's a little bit about Jared. Jared, I'm going to hand it over to you at this point to take us through. We've got about 30 minutes, and we'll let you take it from here.
Awesome. Yeah, thanks, Jeff. Yeah, thanks everyone for joining and for your time. I'm excited to tell you about what we've been working on for a while as research, and now are commercializing at scale with Keiro. And we'll walk through the theme, why this is so important to us, and why it's so timely as well. And so maybe first, just to frame this discussion a little bit, one of the motivations for me working on this theme called compound systems that we started during my PhD, working on infrastructure with Mithril, is I think it's really important that the frontier have a lot of companies participating, contributing, that just OpenAI and Anthropic, for example, aren't the only companies at the frontier with leading AI. And so if there are new teams, young teams, new teams, and proven teams that have an idea, how do we help them get to scale, manifest the idea in the world? It's on the infrastructure side, how do we help them train and serve their models and move much faster to take the idea out of their heads and put it in the world? And now on the Keiro side, I'll tell you about the work that we're doing to help them get distribution for their models in a really powerful way. And so I'm going to walk you through Keiro and why this is such a powerful theme. So Keiro is a new lab that we've started that developed a model called EB1. EB1 is actually a very unique system. It's a model, but it's actually a model that orchestrates other models in a unique way, but it's consumed as another model. So let me walk you through this. So first off, what is EB1? It's a frontier model that conducts all the other models. So it's a drop-in replacement for GPT-5 or Opus in existing customer workflows. Very simple for people to adopt. And they buy EB1 the exact same way that they would GPT-5 or Claude. They evaluate it, they treat it as a model, but it's not just a single model, it's actually a learned conductor. So it's almost a CEO model that was trained explicitly to understand what are Anthropic's models better at than GPT's models, better at than Gemini's models, better at than Grok's models, better at than open source models. And then to take a task and to delegate that task, either in part or in full, to a model or to teams of models, right? And so if it's a really simple request, it might go to a single model. And for more complex requests, it might go to an entire system of models. And you can almost think of this idea of systems as models, systems of models as, basically spinning up a company or a team specifically for a given problem. And one of the reasons it's so powerful is you can do something with models and agents that you can't with humans. A conductor model like EB1 can found an entire company of 100,000 agents, 100,000 people, right? Any mix of job titles, any mix of seniorities, instantly. any org structure you want, just for a specific task that exists only for 2 seconds, 10 seconds, 10 minutes, 10 hours. And then the company, shrinks to 5 people, then expands back to 100,000 or 200,000, and then, then vanishes. That's something you obviously can't do with people. It's obviously a really powerful paradigm. So the question is, what's the most effective system for a given problem, and how to spin up those systems? That's what EB1 does. It's really powerful. It's a new Pareto frontier. So it's better in cost, quality, and latency across a very wide set of tasks. It's extremely general. And yeah, the margins of serving EB1 are very good. So Keiro earns the difference between the EB1 token pricing and the downstream provider costs of the models that it delegates to. And there's a really nice spread, and we'll characterize this more. But it's a really powerful paradigm. So now I'll switch to demo, but I want to emphasize this key point, which is we took a lot of really complex research that we've worked on for years, I'll tell you about, and decided to make it available to people as a single model that is a single line of code replacement in existing workflows. So this is really important. Reducing the education burden, reducing the adoption burden. Customers can just try it out. So let me actually show you EB1 and give you a little bit more intuition for what's going on here. So first I'll show you something in the browser, and then I'll switch over to the terminal to show you a bit of a behind the scenes view. So first, starting off in the browser, EB1, this is an EB1 efficient preview. There's several versions of EB1. It's a model, and just like any other model, you can ask it questions, and it answers the questions, and it's quick, etc. That's not, nothing crazy there. But actually, if I go behind the hood and show you what's going on in the terminal, you'll have a bit more intuition for what's unique about EB1. So let me share my full screen. Yeah, so if I switch over to the terminal, let me make this a lot larger. If I switch over to the terminal and run a client-side API in admin mode, I can show you kind of what's going on underneath the hood. So this is EB1 efficient preview. As I noted, there's many versions of EB1 under model. There's EB1 efficient preview, EB1 preview, EB1 frontier preview, different names I'll explain what the differences are, and then a bunch of variants that we're testing. But I'm just running EB1 efficient preview. So if I ask what is NVIDIA, this is a really simple question that any model can get right. And so EB1 very quickly discerns this. EB1 efficient preview cares mostly about cost and latency, slightly more than other models. Overall, EB1 efficient preview is Opus level quality. But for a simple task like this, there's not really a difference between Opus and Gemini. So it decides very quickly in 26 milliseconds, which is very fast. It's a big model. We did a lot of things to optimize the speed of it. It decides that it's just going to use a single model for this task, and that it will go ahead and use Gemini 3.1 Flash Lite from Google. It answers the question, and then actually it shows there's a few metrics being printed here from this model. So one metric is the overall latency. Only 26 milliseconds was the conducting latency of EB1. In this case, just routing because it's a single model. And the rest of the latency, 1.6 seconds for the first byte, and then 4.1 seconds for the full completion, is all Gemini. So this is de minimis within the range of jitter, not really adding latency at all. In fact, though, this is quicker than Opus, and the cost to a user for this Opus quality model is 80% lower than Opus, but we're also making 70% gross margins on this query because we use Gemini, which is a very cheap model. So that's kind of how that works. If I show you a slightly harder request, I think I ran one recently, like write a very efficient CUDA kernel for sparsing matrix multiplication using the CSR format, EB1 knows that this is a task that is too complex for a single model of this generation. This is the current production weights of EB1. And so it actually decides to spin up a network of networks. And within 59 milliseconds, it comes up with the plan. And this is a network of networks, meaning it's creating an entire neural network of networks, meaning using multiple models and a team. And then those models are collaborating intelligently, and it's still streaming, which is a big technical breakthrough. And so it's going to print CUDA code for this kernel. This actually might take a while because this is a fairly complex task. I'll actually interrupt that and show you what happens if I actually switch to the newer weights of EB1 and run that same query to make a cool point. So now the newer weights of EB1 actually know about GPT 5.5 and some of the newer models from OpenAI and Anthropic. And this latest model from OpenAI, 5.5 versus 5.4, was actually trained explicitly on kernels. So this task that in the prior generation was beyond what a single model could do and required a team of models is now simple enough that a single model can handle the task. So EB1 decided, within 42 milliseconds to give it to GPT 5.5, which now GPT 5.5 is running internal thinking and will start to stream in a minute or two. This is a fairly hard task for GPT 5.5, so it might take a little while. But that's kind of EB1. You kind of get the intuition now for what's going on underneath the hood. So it's a powerful, powerful system. This system, coming back, and now resharing the slides, this system is dramatically outperforming single models at lower cost and lower latency overall, while providing us with a lot of margin. And we'll explain kind of what's going on here with EB1. So the founding thesis is that there's kind of a missing piece. We've been doing work on this field of compound AI systems, what we call it, for several years, and we published that work and made it available. And some of the things that we felt like needed to happen are happening. I'll walk through those trends, but there's kind of a missing piece, which is why we built EB1. So what's already happening? Let me actually exit this PDF presentation mode so you can see the slide slightly better. So one of the first key trends or dynamics to understand is that these models are complementary. No single model dominates uniformly at the frontier. So even within a narrow domain like coding, you can see some interesting dynamics around these models. So this is an analysis from Surge AI, which is a major data provider. And they looked at a prior generation of frontier models, Sonnet 4.5 and GPT-5 Codex from Anthropic and OpenAI respectively, and compared the models. And they found a couple of interesting facts. So firstly, Sonnet was better than GPT-5 Codex, which matches people's general understanding that Anthropic is ahead on coding, but only by about 5%. Sonnet, though, is more than 2x more expensive than GPT-5 Codex, right? So that's interesting in and of itself, but actually more interesting than that was this point that they made, which I think is a key point of our thesis on this idea, which is that roughly half of each model's failed tasks were passed by the other model. So even though their scores look similar, the way they get to those scores are very different. Roughly half of each of the model's failures, the other model passes. So they're very distinct in terms of their affinities, in terms of the way they reason, in terms of the things that they're good at. Just like humans, right? Among frontier athletes or frontier basketball players, there's big differences between Wembanyama and Steph Curry, right? And they may be better at different types of plays or something. And same with these models, right? Maybe that's an analogy that's somewhat helpful. I've been see if it resonates, right? So that's one big trend. The second big trend is that the dynamics is that the cost of intelligence is falling precipitously, which reflects that this AI token market is extremely dynamic and complicated. And so, for example, if you peg to a certain level of intelligence and capability, the price very conservatively has fallen roughly 1,000x in 3 years, 10x per year. Depending on actually who you ask, it's falling faster, and depending on what you peg to, it's falling faster. So Sam Altman often quotes Epoch AI's 40x per year number for frontier intelligence. And Epoch AI also says that there's a different number of 900x per year, depending on what you peg to. Despite the costs falling on a like-for-like basis, obviously token spend is growing rapidly, meteorically, which is part of why we see, the revenues of these companies scaling, right? And so that's the whole point. I can dig into that more. The point is it's very dynamic. In addition to the cost falling, we're seeing that there are many more providers providing a wider range of model options. So when Ling Zhao and I first started work on compound AI systems, there were only two models, GPT 3.5 and GPT-4 from one provider, OpenAI. There's no Bard, there's no Gemini, there's no Claude, there's no DeepSeek, no Kimi, no Minimax, no GLM, none of this stuff, right? Now there's all these providers and a bunch of new Neo labs that will release models soon, in addition to models from Microsoft and Amazon and such, right? And so there's a lot more models. And because of all these models in the ecosystem, there's a massive dispersion that's emerged between the most expensive models and the cheapest models, where the price on a like-for-like basis, on kind of a per million input tokens, per million output tokens basis, spans 215x on input and 645x on output among frontier models, right? If you go back a generation or two, the price difference is 15,000x depending on caching between a million tokens from one model versus another. That's a massive difference, right? I don't think there's any other area of the economy in history where for an equivalent thing, you can see a price dispersion that large, besides maybe like, the luxury purses or something like that, but not in infrastructure not in B2B as far as I can tell. And so that's a big deal. And this is going to persist because distillation, a technique that Jeff Dean and Oriel Vinyals and Jeff Hinton initially helped pioneer and popularize, is really good. It works really well, and we're specializing in distilling large models into small models, dropping the price there. But then also we're pushing the frontiers of test time compute on the other side, pushing cost. This matters because that dispersion is the raw material of orchestration margin, right? Every misrouted, misallocated token is money or quality left on the table. And this is going to start to matter more and more as the scale of spend in the tokens become more consequential economically. What all of this basically means when you compose these separate points is that composition dominates a classical approach of using a single model along the entire proto frontier, right? And so this is really powerful if you can use the right model for the right task, if you can take simple tasks and use cheaper, faster models that saturate the level of intelligence necessary for that task. And then if you can choose the right model or system of models for the more complex tasks, you can push the proto frontier dramatically. And this is what EB1 does. Another really important point to distinguish, just kind of having a really simple ensemble or really simple routing approach from what we're doing with EB1 now is this point here, which is there's a big gap between a naive routing or composition approach and a frontier one. This is why we decided, instead of just publishing research and starting conferences and letting individual companies implement heuristics for routing and model selection downstream, we decided this is actually a frontier lab level problem that requires frontier lab level intellectual force applied against it. So here's an example. So this is a composite coding evaluation that we use internally. And the kind of best single model is Opus, at least at the time of this eval, which was about 0.9% better than the next best single model, GPT 5.4. EB1 was several percentage points better than Opus, which is pretty meaningful in this composite, at roughly 6x lower cost. That's meaningful on its own, but actually that's not the key point. The key point is this oracle, which is we did an evaluation saying if you chose the exact right model for the exact right task, what's an example of a frontier point that in that oracle space? How much better could you do? And the point is you could be more than 20% better at a greater than 30x lower cost. And that was extremely inspiring to us. This is the research in there, right? This is, we're trying to kind of climb up and to the left in this case, right? And that's what each new generation of this model is doing. It's learning how to more intelligently select the right model for the right task. And this is, not something that, this is a very, very difficult task. So to put this in perspective, I would argue that the most, cracked or the most kind of technically, frontier teams within the frontier labs, Noam Brown's team at OpenAI, et cetera, these teams are the multi-agent teams, which are figuring out how to use multiple instances of cloud, multiple instances of Gemini for Pro Deep Think, multiple instances of OpenAI's of OpenAI's models to push the proto frontier to solve hard problems in science, et cetera. But the issue is they're doing that within the kind of closed model family of their own lab. We're doing that across model families in a way that's really powerful. And this is a really difficult, really valuable task. And this is what we're climbing with Keiro. And so, obviously we've run a lot of evals ourselves, and EB1's obviously much better at our evals, but we find it much more inspiring to show instances where our partners and customers took EB1 and ran it on their own private data, on their own private evals, and got some awesome results. So I'll walk through a few examples of that to demonstrate kind of what EB1 can do. So here's a really cool one. This is from Harvey, which is the legal AI company. Some people may be familiar with it. This is actually kind of an intermediate result, and it's not perfect, but it's actually kind of cool. This is with EB1 Preview, not EB1 Frontier Preview. With EB1 Preview, they showed that EB1 Preview was much more cost-effective than both Opus and GPT 5.4, while beating GPT 5.4 pretty dramatically, but it still lagged Opus on quality. EB1 Frontier Preview has since bested Opus by quite a bit as well, but this was an intermediate point. And yeah, it was a frontier model with much better economics. And that was exciting to us and to them. We ran this eval with some of the team from Nebius as well, where they have this great benchmark called SWE Rebench. And we took some tasks from that SWE Rebench. And yeah, essentially on that task, EverGreen did a really, really cool job where it submitted, beat GPT-5.4 codex and Opus pretty dramatically. It did it in some cool ways. So it ended up being slightly more expensive. It was $89 versus $86 per submission on average. Comparable to codex, but the total cost was slightly higher because it's submitted on more instances. And it got there in an interesting way. So it actually used networks of networks or teams of models, systems of models for more steps, spending more per step. But it actually was able to converge on some of these tasks in 30 to 66 steps, where Codex, for example, would burn 450 to 500 steps without converging. So that's pretty cool. And Opus ran out of budget, which is pretty cool. Databricks ran this eval. That's pretty cool. So they have this eval called Office QA. It's a grounded reasoning benchmark that takes a bunch of documents that are unstructured, and the agent has to navigate the documents, find the relevant data, extract the data, and then reason about the data to answer questions and run calculations to a very, very fine tolerance, like 1% tolerance. And yeah, EB1 Frontier Preview beat all the other models on this benchmark in a way that was pretty exciting to all of us. And we've since done even better with the latest generation of EB1. And there's some other great ones, including a paper from IBM that's in the appendix that they actually published in NeurIPS, where they, IBM Research got early access to EB1 through a partnership between Skylab, which our founders are involved in, and IBM. And they actually had early access, so ran it on some of their research problems, made a lot of progress on this set of Frontier CS problems, and asked for our permission to publish. And yeah, they published and submitted to NeurIPS. And I can show you that in the appendix if anyone's interested. Just ask in the comments. But yeah, I'll wrap up with this slide, which is, I think one of the kind of key points is our team decided to do this because we felt like we needed to. For years, we've just been publishing papers, starting conferences on this theme of compound systems, which spans and encompasses 3 different sub-themes. One sub-theme is the theme of model routing. We're going back to 2023, Ling Zhao, our co-founder, created this paper called Frugal GPT, which showed that you could cut costs 98% with no perceptible drop in quality if you could properly select the right model for the right task intelligently. That created this whole subfield of model routing, and he pushed that further with LM Selector. Matei started the sub-theme along with some other students called prompt optimization, which has resulted in these really powerful, popular frameworks and papers like DSPy and JEPA, which are really popular in open source. And then I started this subfield during my PhD that I focused a lot on, which was basically called networks of networks, which we talked about, which is this idea of if you're willing to make 1,000 calls to GPT-5, create an entire company of GPT-5 models, can you get GPT-6 level performance early, basically? And we studied the dynamics around that, and that resulted in a number of different papers and themes. And there's now a whole subfield of major conferences like the ACM KAIST conference dedicated to it as well. And we basically realized that these themes had a lot of impact individually, but nobody in the field was combining them in the right way, despite our consistent urging and insistent urging and evangelism. So we decided to combine them in the way that we thought necessary into one model, AB1, which is a coalescence of all these ideas made commercially available. In addition to these subfields, we also have, I think, unique experience that we realized the rest of the market didn't have that was necessary, including frontier pre-training experience. I was on the core deep learning team at DeepMind starting in 2019. And so we've trained models at the larger scale early in the field. GNNs, which we brought a lot of key ideas from GNNs and recommender systems into EB1 in a way that was really critical. But then also systems and serving, which we use to serve EB1 really fast and also use to train it very cost effectively, which our team is very unique in, being both ML theorists, but also having ML systems experience. And we've developed a lot of these systems across Mithril, Tigris, Demeter, and also things like VLM, Ray, and Spark with Matei and Young. So that's what we saw necessary. This research is great, and we've done the research for years, but the research is the moat, it's for foundation, but the point of Keiro is the business. And our goal with Keiro is to take this research, commercialize it at massive scale. We think that there's a short window in which to make Keiro a massive company that rivals Anthropic and OpenAI, so we change the dynamics in the space. If we succeed with Keiro, then the AI model space will look more like TikTok than like radio, right? And by that analogy, I mean radio, news, you have a few stations, a few news channels that define the narrative. With TikTok, you have obviously thousands, hundreds of thousands, millions of creators plugging into one channel. Same with YouTube, and that's a much more inspiring future to have many teams with new ideas, new approaches, participating, getting some distribution, and scaling on the basis of the quality of their models, versus one or two big model companies, or three maybe, controlling everything with trillions of revenue, dominating things economically, geopolitically, etc. So we think this is really important, and that there's a window of time to scale this business. So with Keiro, we're commercializing EV1 to move extremely fast, and working with great partners, investors, assembling a great team, and working with great distribution partners, customers, etc., to really scale EV1 quicker. And this EV1 aligns with the strategic goals of everyone from NVIDIA on the chipmaker side to Amazon, and Bedrock on the cloud side to Databricks, Harvey, and others on the model side. Everybody's main concern, the top question on the minds of every leader in the space right now is, are we going to end up with two frontier labs owning everything and verticalizing, or will there be many models competing? And that's the top question for everyone, almost everyone now at this point. And Keiro's our answer to that question. So I'll pause here. We have an appendix with a bunch of slides as well, and happy to take questions and talk about these other things. But thanks for your attention.